In this video, we will be talking about how to solve systems of linear equations using elimination. And with elimination, we multiply one or both equations by a factor if necessary, and then we add the equations together to eliminate either the x's or the y's, and then we solve, and we substitute the variable back into the equation to solve for the other, and then we can also check by our solution by substituting back into the original. So let's take a look at one problem. So, like I said, we add the equations together, but just for a second, before we do that, let me just show you. If you have an equation, like say 2 plus 3 equals 5, that is a true statement. 2 plus 3 does equal 5. Let's write another one. Let's say it is 4 plus 6, that equals 10, another true equation. Now, look what happens. If you add 2 and 4, you get 6. If you add 3 plus 6, you get 9. And over here, if you add 10 plus 5, you get 15. And indeed, 15 does equal 15, so you still have an equality. So we're going to use that idea to solve using elimination. Now in this case, if we add the x's together, because one is a positive 4, one is a negative 4, we end up with 0x, so that cancels. And then we add the y's, we have 5y equals 25. And now we only have one variable, so we can solve. So y equals 5. And now that we have found one of the variables, we just substitute that back in for y into either of the original equations. It doesn't matter which one you choose. So we'll take the first one, 4x plus 2y, but instead of y, we'll put 5. And then we solve that for x. So 4x equals negative 1. Divide by 4, x equals a negative 1/4. And if you substitute back into the original equations, 4 times negative 1/4, that would be negative 1. 2 times 5 is 10. Yep, that gives you 9. Negative 4 times negative 1/4 would be a positive 1. 3 times 5 is 15, and yes, that gives you 16. So let's look at another problem. 2x plus 7y equals 4. 3x plus 5y equals negative 5. Now, if I were to add these equations together, I would have 5x plus 12y equals negative 1. And that doesn't help me right now because I'm not eliminating either the x's or the y's. So what I'm going to do is I'm going to choose which I want to eliminate, the x's or the y's. In this case, let's just eliminate the x's. So what we'll do is we will multiply. We say, okay, what do 2 and 3 go into? Well, they both go into 6. So I'm going to multiply the top equation by 3. And the bottom equation will multiply by a negative 2, because if this is positive 6, I want this to be negative 6. Remember, whatever you do to one side of the equation, you have to do it to the other side. So now I'll rewrite the equations. The top one would be 6x plus 21y. Remember, you have to use a distributive process. And then we have 12. In the second equation, we have negative 6x minus 10y equals 10. And now, when we add the equations, the x's cancel. We have a positive 11y equals 22. Divide by 11, y equals 2. And so there's part of our solution. And now we substitute that back up for y into either equation. We'll substitute into the first one. So 2x plus 7 times 2 equals 4. And so we subtract 14 from both sides. 2x equals a negative 10. Divide by 2. X equals a negative 5. And there is the other solution. So let's try another one. Now, last time we decided to get rid of the x's. Well, this time let's get rid of the y. So 2 and 7. Well, those both go into 14. So let's make the top number a positive 14 and the bottom a negative 14. So to do that, we'll have to multiply the first equation by 2 and the second equation by a negative 7, because 2 times 7 is 14, negative 7 times 2 is negative 14, so the y's will cancel. So we distribute, and then in the second equation we distribute. Always remember to multiply both sides of the equation. So we end up with a negative 29x equals 58. And so we divide. So x equals a negative 2. There's one part of our answer. And again, substitute back into one of the originals. 3 times x, which is a negative 2, plus 7y equals 15. And then we just add 6 to both sides. We want to isolate the variable term. And then lastly, we'll divide by 7. So y equals 3. And there's your solution. Next, we'll look at these equations. Now, these look quite similar. So let's say we wanted to get rid of the x's. Well, we'd have to multiply the top equation by 2. So we have negative 2x plus 2y equals negative 4. And then the other equation is 2x minus 2y equals 0. So then when we add them together, well, this cancels and this cancels, which in other words, we have 0 left on this side, and over here we have a negative 4. Well, that's not true. These are not equal. So we would say we have no solution. But why is that happening? Well, let's look at these equations a little more closely. Minus x plus y equals negative 2. Let's solve that for y. So that would be y equals x minus 2. And the other equation, 2x minus 2y equals 0. So again, we'll solve for y. And divide both sides by negative 2. So y equals 1x plus 0. There's no y-intercept there. But notice in both of these, we have the same slope and different y-intercepts. So we have parallel lines, which means they're never going to cross. So there is no solution. And so when you're trying to use elimination or substitution, when you come up with a false statement, that's what's really happening, is you have parallel lines and no solution. So in the next one, you'll maybe notice that if you multiply the first equation by 3, you would have the same equation. So let's just try that. And actually, let's multiply by negative 3. Like, let's say we were just going to try to cancel out the x's. So we would have negative 12x minus 3y equals negative 18. Right? So now if you add those together, this cancels and this cancels, so you have 0. This cancels, so you have 0, which is true. So that is going to be an infinitely many solutions, or IMS you can write. Now again, let's look at those equations and solve for y. So in this first one, y would equal minus 4x plus 6. In the other equation, we would have 3y equals minus 12x. If I bring the 12x to the other side, plus 18. Divide everything by 3. Y equals then minus 4x plus 6. They are the same equation. So we would say that these are coinciding graphs, or coinciding lines then. So in that case, infinitely many solutions. And the last thing I just want to talk about is how do you know when to use substitution? How do you know when to use elimination? Well, the truth is you can use substitution, elimination, or graphing on any system. It's just that sometimes one method or the other might be easier. Now, a problem like this, if you wanted to solve for y, you would end up with fractions, like y would equal, let's just do that real quick. So you subtract the 2x, 3y equals minus 2x plus 6, and then you divide by 3x. You don't, yeah, you do end up with fractions. So y would equal negative 2x, 2/3 x plus 2. And so when you're substituting in, you would have fractions to work with, so it's just a little bit more complex. So it would be easiest to use elimination. You could just multiply the top equation here, both sides, by negative 2, and then your x's would be eliminated. In this problem, you have a coefficient of 1 right here, so you could just isolate the x, solve for x, so you'd have minus 4y equals 70, or excuse me, minus 4y plus 70, right? And so then we can just substitute back in. So substitution works nice when you have just a plain x or a plain y, and you can solve for that in the equation. So that's it for this lesson. Let me know if you have questions. Thanks for watching.